A very good morning, students. Myself Asha, Assistant Professor of Mathematics, Government First Grade College, Kyarpuram. I hope you are all safe at home. Please stay home, stay safe. I know you are in dilemma situation. Your exams are not yet over, but we have to start the second semester syllabus as per the government rules. So in this semester, I'm going to handle the chapter differential equations. So this chapter carries 19 marks. Okay, 5 marks, 3 questions you will get, and 2 marks, 2 questions you will get. Totally, you will get 19 marks in this chapter. So all are familiar about. I hope all are familiar about the differential equations, right? Right. So what is the equation? First, let me check. Let me explain what is equation. So there are. I have given 4 equations here. The first equation, second equation, and this is third equation and the fourth equation. Okay, these three equations are in one way, means one type, and this is in another type, right? So differential equations means the equation contains the independent variable, dependent variable, and their derivatives is called as a differential equations, right? Okay. In the first, second, and third equations, only the dependent and independent variables are present. But in the equation 4, it involves their derivatives also. So this is called as a differential equation. We will see so many applications related to the differential equations. Okay. So I think all are familiar about the degree and the different order of the differential equations, right? So what is the order and degree of the differential equations? Suppose I have given example here. So this is the equation, differential equations. This is differential equations. What is the order and degree of the differential equations? First we should find out the order. So what is the order? The order means the dy by dx is stands for the first order. D square y by dx square is stands for second order. D cube y by dx cube is stands for the third order, and so on, right? So first in this equation we have to consider the highest order present. So this is first order and this is second order, right? So the second order is the highest order. So the order of the differential equation is second order, right? So next is degree. We have to consider degree. Here the highest degree is 3. Okay, right. But the degree of the differential equation is 1. How? We have to consider the highest order power. Here the highest order is 2. The power of highest order is 1. Okay. So that is the degree of the differential equation. So this is second order first degree differential equation. This is very basic. I hope you are all studied in second PUC, right? I hope. Okay, this is very basic of differential equations. So according to your syllabus, this semester we are going to study the differential equation of first order and first degree. Okay, first order, the first order, first degree. First order is the differential equation contains dy by dx. First degree means the power is 1. Okay, so the general differential equation in the form of f of x comma y comma dy by dx is equal to 0, right? X is a independent variable, y is a dependent variable. This is the derivative of this. Okay, we have to find out the solution for this equation. The solution can be written as f of x comma y comma c is equal to 0. This is the differential equation of first order first degree, right? Okay. So there are so many types of solving the differential equations. So first we are going to study the linear differential equation. There are so many terms. Exact differential equations, equation reducible to Bernoulli's form, and solvable for P, solvable for X. So many types are there. This is the first type, means first technique to solve the differential equation, that is linear differential equation, right? Linear differential equation. Okay, a differential equation of the form dy by dx plus py is equal to q. I'm taking this as equation 1. This p and q are the functions of x, or sometimes it may be a constant. Okay, this type of equations are called as a linear differential equation of first order. Okay, how to solve this equation? First, we should find out the integral factor. So after finding the integral factor, we should find out the general solution of this. Okay, how to find out the integral factor? So the integral factor can be represented as IF. IF is equal to e to the power of integration of p into dx. So the finally the general solution can be represented as y into integral factor is equal to integration of q into integral factor into dx plus some integral constant. This integral is not applicable for this c, right? This is the general solution for the above differential, means linear differential equation. The linear differential equation is of the form dy by dx plus py is equal to q. There is no coefficient for dy by dx. Okay, suppose if you in solving the problems you may get some coefficient for this dy by dx, what we have to do? We have to remove that, means the whole equation is divided by that, then we can remove that, right? So this is differential linear differential equations. Clear? For the linear differential equation, first we should find out the integral factor. After that we go for a general solution. The general solution is y. In the left hand side, y into whatever you will get the integral factor, that you should multiply in the left hand side, is equal to the integration of q. It is a q is there now. The q into integral factor dx plus some integral constant, right? Okay, this is the way of solving the linear differential equation. First we will check the first problem. Solve the linear differential equation. The first problem is dy by dx plus 2 by x of y is equal to x cube. This is the given problem. You can compare with the linear differential equation. That is, linear differential equation is dy by dx plus py is equal to q. So compare these two equations. What is the value of p here? Coefficient of y, right? Coefficient of y is p is equal to 2 by x, right? What is q? The q is x cube. Okay, first I should write what is p value and what is q value. So after that, I am going to find out the integral factor. So the integral factor is equal to e to the power of integration of p into dx. So the same step, in the next step, e is equal to integration of what is p? The p is 2 by x. Just I am substituting the value 2 by x into dx. Okay, e into, here 2 is a constant. Integration of 1 by x is log x. Okay, e to the power of 2 into log x. So this 2 log x can be written as, we know the formula a of log b, a log b, right? A log b can be written as, you see, a, so a log b is equal to log of b to the power of a, right? B to the power of a birth, right? This a becomes the power. So this can be written as like this. In the similar way, e to the power of 2 log x can be written as e to the power of log of x square. We have a formula, e to the power of log of f of x can be written as f of x only. So here e to the power of log of f of x is, you will get only the x square. F of x value is here x square, right? So our integral factor becomes x square. Okay, e to the power of, sorry, see, e to the power of log of f of x, right? Log of f of x is equal to f of x only. This is a formula. By using this formula, we can write in place of this f of x, we have x square. So this can be written as only the x square. So the integral factor becomes x square only. This is the way of calculating integral factor, right? So after that we have to find out the general solution for this. So the general solution for the formula y into integral factor is equal to integration of q into integral factor dx plus c, right? So in the next step I am writing y as it is. What we got for integral factor, this is x square. I am just substituting, and integration of q. What is q? This is x cube, right? I'm just substituting q value x cube. The integral factor is x square into dx plus some integral constant, right? Just I'm simplifying this. Y into x square, x cube into x square is x to the power of 5 dx plus some integral constant. Then I'm going for the integration. So x to the power of 5 integration is x to the power of 6 by 6 plus some integral 6, right? I've already told this integration is not applicable for this c, right? Then I'm taking this x square to right hand side. Then x to the power of 6 by x square, you will get x to the power of 4 by 6 plus c divided by x square. In the next step, we can write this x square as x to the power of minus 2. So x to the power of 4 by 6 plus c into x to the power of minus 2. If you want, you can write, or else you keep it like this only. This is the way of solving the linear differential equation. Got it? Okay. So then I have taken the second problem. This is related to trigonometric functions. So solve the differential equation dy by dx plus y secant x is equal to tan x. So same thing, you can compare this with a linear differential equation, that is dy by dx plus py is equal to q. Then after that you write what is p value and what is q value. So what is p? The coefficient of y, right? The coefficient of y is secant x and the q is this tan x. After this we should write the integral factor. The integral factor is equal to e to the power of integration of p into dx. Okay. So integration of secant x is what? Log of secant x plus tan x. Okay, so e to the power of log of secant x plus tan x. I already explained e to the power of log of f of x can be written as f of x only. Here the f of x value becomes this much only, right? This much only. Secant x plus tan x. So finally I got the integral factor is secant x plus tan x. Okay. So secant x plus tan x. This is our integral factor. So after that we can find out the general solution for that. Y into integral factor is equal to integration of q into integral factor dx plus c. Just I'm substituting the integral factor and q value here. So y integral factor is secant x plus tan x is equal to integration of q is tan x into secant x plus tan x, right? Plus c. Just I'm substituting the value. In the next step I'm going to multiply tan x into secant x, right? Tan x into tan x is tan square x, left hand side as it is. Clear? Okay. So in the next step I'm keeping the terms as it is, okay, except this tan square x. We know the formula, 1 plus tan square x is equal to secant square x. So by using that, the tan square x can be written as secant square x minus 1, right? Okay, then after that I'm going to integrate this, the left hand side as it is. The integration of tan x secant x is secant x. The integration of secant square x is tan x. And the minus 1 means 1 integration with respect to x is x plus some integral constant. I am taking this y coefficient, means the secant x plus tan x, to the right hand side. So then what I'll get, secant x plus tan x divided by this is equal to 1, right? Plus, I'm taking the reverse order this c minus x. Instead of minus x plus c, I'm going to write this as c minus x. That can be divided by this secant x plus tan x. This is our general solution for the problem, right? Okay. So next I'm going to take the next third problem, that is 1 plus x square dy by dx plus y is equal to e to the power of tan x. Okay. So our linear differential equation is dy by dx plus py is equal to q. There is no coefficient for this dy by dx, right? In the standard form. But in the given problem, we have a coefficient for dy by dx. So what we have to do? We have to remove this coefficient 1 plus x square. For that what we can do? We can divide the whole equation by 1 plus x square, right? So what we will get? Dy by dx plus y divided by 1 plus x square is equal to e to the power of tan inverse of x by 1 plus x square, right? Now we can compare with the standard equation this. Now you can write the what is the p value and what is q value. P value becomes 1 by 1 plus x square and q value is equal to e to the power of tan inverse of x by 1 plus x square. The procedure is same. First we should find out the integral factor. So integral factor is equal to e to the power of integration of p into dx. Okay, here p value is what? 1 divided by 1 plus x square into dx. What is the integration of 1 divided by 1 plus x square? Tan inverse of x, right? So the tan inverse of x. So here you can't write the only the tan inverse of x because the log term is not there. So our integral factor becomes e to the power of tan inverse of x only. You can't write the single function here. Okay. So then by using this integral factor, we have to find out the general solution for this. So the general solution is y into integral factor is equal to q into integral factor dx plus c, right? So the integral factor is e to the power of tan inverse of x, right? So I'm just substituting the value. Q is what? E to the power of tan inverse of x by 1 plus x square, and the integral factor is e to the power of tan inverse of x dx plus c. So e to the power of tan inverse of x, e to the power of tan inverse of x. So bases are same, we can add the powers. Tan inverse of x plus tan inverse of x becomes 2 tan inverse of x, right? So next we can't integrate this directly. So that's what we go for a substitution method. So think about it. So what we have to take for the substitution? So if I take this 1 plus x square as t, if you differentiate, you will not get the any other of the terms here. Okay. So if I take tan inverse of x, if you differentiate, you will get 1 divided by 1 plus x square. Your term is there. So that's what I'm taking tan inverse of x is equal to t. So that if you differentiate this with respect to x, then you will get 1 divided by 1 plus x square into dx is equal to dt. In place of this, you see 1 divided by 1 plus x square into dx, we can write it as dt. Okay, y e power tan inverse of x we have taken t, right? Y e power t is equal to integration of e to the power of 2 times of tan inverse of x can be taken as t, and in place of dx divided by 1 plus x square can be written as dt plus some integral constant, right? So in the next step, e to the power of 2t integration is e power 2t by 2, right? Some integral constant. Next I'm going to substitute the t value what we have taken for t. So I have taken for t is tan inverse of x, right? So I substituted the value. Okay, this is our general solution for this. So next if you wanted to take this e to the power of tan inverse of x to right hand side, we will get e to the power of tan. If I comes to the down, one one tan inverse of x, one tan inverse of x get cancelled. So you will get e to the power of tan inverse of x by 2 plus c by e to the power of tan inverse of x. If you wanted to take into numerator, it will becomes negative e to the power of minus tan inverse of x if it comes to numerator, or else you keep it like this only. Okay, this is the solution for the given problem, right? Understood? So I think I have solved the three problems. Next, I have given two more problems for exercise. Okay, you can solve this. So I have given one more conditions here. Y of pi is equal to 0, right? So it means that this is x value, this is y value. Okay, at the after finding the general solution, you can substitute the x value and y value for the final value, means final solution. You will get c value. Okay, you will get c value. Suppose for the same problem, if I give y of 0 is equal to 0, y of 0 is for this problem, for the y of 0 is equal to 0, it means that x is equal to 0 and y is equal to 0. I am just explaining. Wait. Y of 0 is equal to 0. It means that x is equal to 0 and y is equal to 0. Where in this, wherever there is x and wherever there is y, just you put x is equal to 0 and y is equal to 0. Here 0, right? Wait a minute. You will get 0 is equal to e to the power of tan inverse of x is equal to what? Tan inverse of 0. Tan inverse of 0 is 0 only. Okay. So then e to the power of 0 is 1. Then you will get to 1 by 2. Okay. Plus c by 0. Right. It right. C by 1 you will get. C by 1 you will get. Okay na. So you are getting in the next step c is equal to minus 1 by 2 you will get. Right. So this is the c value. This is the way of calculating the condition if the condition is given. Clear? For the but for this problem, the textbook they are not given the condition, so that's what I have not applied. Just I'm explaining how to apply the condition. Okay. Okay. This is the way of calculating this. Okay. And I'm sending this first method, the linear differential equations. Okay. Along with this, I'm sending the differential equation whole PDF of your textbook, not the notes in your for your textbook. I am sending. So, if you want more problems to solve, you can go through the textbook and you can go through the exercise. You can solve it. If you have any doubts, feel free to ask me. I will explain. Okay. So in the next video, I will send next method. Okay. If you have any doubts, you can WhatsApp me personally. Don't put it in groups. Okay. I hope I explained well, right? Okay. This is linear differential equations. Clear? Very simple. The differential equation is standard form is this. So if it is not in the standard form, you can convert the equation to standard form. After that, you can find out the integral factor by using e to the power of integration of p into dx. After that, you go for a general solution. Y into integral factor is equal to integration of q into integral factor dx plus some integral constant. Very simple method. It is a linear differential equation. Clear? This chapter carries 19 marks. Okay? Okay. Okay. Please stay home, take care of your health and do some exercises at least at home. You can practice some yoga or Surya Namaskar or something. Take care of your health and eat nutritious food. Health is very important. Okay? Health is wealth. Okay, take care of yourself and see you in the next video. Okay, thank you. Thanks for listening.